Right. Good afternoon, everyone. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through these unforeseen circumstances due to COVID-19, we wish everyone and their families a safe time, and we will hope to pass through this together soon. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from 90 different countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference. And the papers will be published in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for this conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of knowledge and interactive sessions. I would like to welcome you to the technical session number 2 and further introduce you to the chair of this session, Dr. Chakchai Soin. He is a professor of computer science at the Department of Computer Science at Cone University, where he received an engineering degree in 1999 and 2001 respectively, and a master's and PhD from WUSTL USA in 2006 and 2010, all in computer engineering. In 2003, Dr. Soin was an internet working trainee in a CNAP program at NTU and obtained a Cisco Microsoft certifications. In 2006 to 2010, Dr. Soin was an intern at Mobile IP Division, Cisco Systems, and WiMAX Forum and Bell Labs USA. His research interests include mobile computing and sensor networks, Internet of Things, computer, wireless and distributed networks, cybersecurity, and intelligent systems and future internet. He is an editor and a guest member of the IEE Access, Intel, Trans Systems, Springer Plus, Mobile Info, Wireless and Mobile Compute. Dr. Soin has authored and co-authored publications, over 100 applications and 10 books, including the IEEE JSAC, the Commune Magazine, Compute, Newton, Android app, Windows Phone app, and the Compute. Let's welcome Dr. Soin.
Hello. Hope everyone hear me, right?
Yeah, we can hear you well.
Yeah, actually, I'm thank you the co-moderator, and I have to say thank you for the Emit and Day that invite me to be one of the session chair, and I believe that this conference will be a prosperity and hope that all of you have the good time here, and hopefully some of you will get selected for the further journal selections. And any question, please let us know. And again, if we are also happy if all of you can submit again in the next years. And I think I'm not sure if I'm only one to be a session chair here, right?
Sorry?
If I am the only one to be the session chair here, or I also have other session chair?
No, you're the only chair here.
Okay, fine. Okay, and then I think I just wonder if there is some people help me to basically record the time.
Yeah, it's recording all the time.
Good. Okay, I think if no question, we just let's start the the first presenter then.
Yeah, of course. First paper, sorry. The first paper goes to Rahel Mekonnen Tamaru. Her paper title is the sentence level automatic speech segmentation for Amharic. Rahel?
Yes, can you hear me?
Yeah.
Hello? Okay, hello everyone. I really appreciate you all for attending today. Can you hear me?
Yeah, we can hear you.
Okay, my name is Rahel and I am here today to present my work, Sentence Level Automatic Speech Segmentation for Amharic. So as we know, speech is a vocalized form of communication used by humans to exchange information. So it's a natural and fast means of communication for people. And modern research in the field of speech technology and at creating strong speech system that can be used for communication between human beings and information processing devices. Unfortunately, the machine capability to interpret speech is still poor. The most difficult feature of speech that challenge machine is its segmentation because human speech is produced continuously. So speech segmentation is a technique of discovering speech signal in different parts. So in speech segment is any one of discrete units that occur in sequence of sounds which can be broken down into sentences, words, syllables, phonemes in spoken language. So the main objective of this segmentation process is to use the result for other areas of speech processing. So it's an essential pre-processing steps in several speech-related research areas, so such as speech synthesis, language identification, speaker identification system. So an efficient, accurate, and simple technique is needed to accomplish these objectives. So it's an essential step towards strong information extraction from speech is automatic determination of sentence boundaries. So in this work, we present an automatic sentence level speech segmentation for Amharic language. Amharic is one of the most spoken Semitic language in Ethiopia with at least 27 million native speakers after Arabic. So in contrast, it has also been identified as under-resourced language. When it comes to the research problem, nowadays one of the hot topics in speech technology is how to develop a system that matches the characteristics of speech, especially spontaneous speech. So information extraction from large audio database requires extracting the structure of audio file as well as their linguistic content. So one of these processes is to add sentence boundaries to automatic transcription of speech contents. So adding this structure of to the automatic transcript is a very challenging task when processing spontaneous speech, especially because this kind of speech is characterized by disfluencies such as field pause, requires station, repetition, and the likes. So the identification of sentence break is confusing both for humans and computers. Different researchers demonstrate that sentence break are critical for legibility of speech transcripts. Moreover, missing sentence segmentation makes meaning of some utterance ambiguous, and similarly, missing sentence boundaries cause significant problem to automatic downstream processes. So sentence boundaries are important when analyzing syntactic complexity of speech, which can be a strong indicator of potential impairment. There is no sentence level speech segmentation for Amharic for Ethiopian language that have done well in other language, even though there are similarities in a form and function of procedure among diverse language, like pause, natural tendency for fundamental frequency. There is a considerable variation indicated by cross-linguistic comparison of prosodic features like different timing of essentially comparable phenomena. and different relationship between all different mutual effects of fundamental frequency, duration, and intensity. So we do not know which features, and their combination will result optimal speech segmentation for Amharic speech. Therefore, this research investigated optimal method which perform segmentation. We used automatic tool for segmenting and labeling of Amharic speech data. The tool is on hidden Markov model, and in this work, automatic speech segmentation is completed by forced alignments. Monosyllable, tied state trisyllable, and monophonic models have been developed to build forced alignment. Rule-based and adabus have been used to differentiate accurate boundaries from the candidate. We use dictionary classifier and support vector classifier as a base estimator in our experiment. So in the first stage of automatic speech segmentation is data preparation. So in order to get optimal speech corpus, we collected data from various sources. Then lexicon are prepared as a pronunciation dictionaries for our automatic speech segmentation system. This pronunciation dictionary for Amharic language is not built yet, so we prepared pronunciation dictionary by taking lexicon as inputs. Then the final stage of data preparation is to parameterize the raw speech waveform into sequence of future vectors. So mere frequency capacitor coefficient is used to parameterize the speech signal into future vectors. So using Amharic speech and text corpuses, we have developed the acoustic model and compiled it into statistical representation of sounds that make up words. And the basic unit of speech used in our research are syllables and phones. We are using HMM in this research to build an acoustic model, acoustic components, and acoustic building process take the pronunciation dictionary, training text corpus, and future vectors of the training speech corpus as a main inputs. Then to line up written words with the spoken words, which are used monosyllable, tied tri-state syllable, and monophonic acoustic model. So the speech, finally, the speech segmenter gives automatically segmented results of the test data set. So in our initial experiment, the speech segmenter takes two main inputs, forced alignment and an audio file. Then from forced alignment, pause futures are extracted. Then the pause duration is calculated and is used to evaluate sentence boundary as a threshold. So in the first experiment, we used rule-based for sentence segmentation. In the second experiment, pause future from forced alignment is extracted. Then a statistical method adabus is then applied to all candidates for sentence boundaries. So with two corpora, read loud and spontaneous speech, we test our methods. Then the percentage accuracy of monophone acoustic model is low in both experiments. This indicates that acoustic model produce slightly different outcomes of forced alignment, and the better acoustic model gives the more accurate to forced alignment. Therefore, the researchers believe that the best acoustic model for Amharic speech to achieve correct forced alignment is monosyllable acoustic model. Then as shown in the experiment, the adabus classifier constantly showed good results, and especially in classifier of dictionary. So dictionary classifier is an optimal classification method for Amharic speech segmentation. So in this paper, the automated speech segmentation system introduced the first for Amharic language. In general, it's accomplished by defining the boundaries in continuous speech signal between sentences. And then these findings are promising and will open a broad door for further studies. We are also working in this area by using neural network-based approach to achieve greater accuracy for this language and to study strong speech and speech-related area systems. It's also important to continue further study in speech pre-processing. So it's also required to conduct a research on automatic speech segmentation for other discrete units such as syllables, phonemes, and word labels. And other prosodic features such as perceptual and linguistic levels. So it's all about. Thank you. And if you have any question, we will come.
Okay, thank you, Rahel. And any question from the audience? Since all of them, I mean, turn off the video, so so anyone has any questions to Rahel? Okay, then I have maybe some questions. Okay, so I just wonder, can you just emphasize a bit what make this particular language different from others, because there are also others language segmentations, right? Can you point out the key difference that make this particular language segmentation different from others?
Hello.
Hello. Did you hear me, or
Yes. Can.
so do you understand my question, or do you want me to repeat again? Okay, let me repeat it again.
Yeah. Okay.
Okay. So what make this particular language segmentation different from other language segmentations?
Okay. While an automatic speech segmentation for other language has been developed by different researchers, most of the studies were performed using only prosodic features directly from the speech to define sentence boundaries. So, and there is no sentence level segmentation for Ethiopian language that have done well in other language to best of our knowledge. So, while there are similarities between various language, such as pose or natural comparison of characteristics, such as different timing of essentially comparable phenomena and different relationship between fundamental frequency and different mutual effects of duration and intensity. The researchers did not use the form of forced alignment for sentence segmentation. So that's what I did.
Okay, let's see. So I mean, it will be maybe if you get selected to be journal, maybe that some examples would be help the audience. For example, you can just point out what kind of example that make the let's say lower accuracy. So can you just go back to the performance evaluation section a bit? Yeah, I was a bit confused here. I just confused what is this accuracy? I mean, and versus the next page classification accuracy, and a bit confused. I'm sorry.
Maybe this experiment is based on rule-based. So, and this one is the statistical method adapts. So, the statistical method adapts the best result, which in this three classifier. But the rule-based is
I see.
low.
I see. It's basically just basically try to compare, right? I mean, the rule-based maybe lower accuracy and compared to the machine learning, right? This is what you want to say, right?
Yeah.
Okay, I see. Can you go? I mean, next page again. Okay, here. So, to me, it seems that decision tree is very good, right?
What?
The decision tree is very good.
Yeah.
And very fast.
Yeah.
No need for training, right?
What?
No need for training. SVM, we need the training, right? This is assume is testing accuracy, right?
Yes.
And
Assume
I
the
assume that
experiment, Adams classifiers constantly showed good results, especially in decision tree classifier. And also the resulting processing time per decision tree classifier is faster than the classifier of support vector machine. So yeah.
But it seemed to me it's quite obvious. I mean, that decision tree is good. So and also I think why don't you try deep learning, CNN or whatever?
Okay. currently we are working on neural net deep learning to improve the efficiency.
Okay, I see. Okay. Thank you very much, and hopefully you can just continue your work, and I think it's very good. If you can have 100% accuracy in a sense. Yeah, we are
Thank
looking
you.
for that, and then who know, right? In the future, I mean, you can have your not one is the segmentation, right? Another one may be the translation, right? We are looking for the translation, right, from your language to English. I mean, it's very good, right?
Okay.
And do you know if the Google provide the your this language translation to English yet?
Yeah.
There is or there is not?
No, there is.
Not?
There is
There is?
Amharic translation. Yes.
And is it very good? I mean, is it high accuracy or what?
Yeah, it's not bad. But it's not accurate that much.
I
but
see,
it's not bad. Yeah.
I see. Okay, very good. We are looking for that, and hopefully. Thank you very much, Rahel.
Thank you so much.
And please, the next presenter, I think, will be the Asma, right? Masur and Kuja.
Yeah, thank you.
Yeah, right. Can you hear me?
Yeah.
Can you hear me? Yeah, okay, good. Should stop. Okay, can you see my screen?
Yes, please.
Okay, so my name is Asma Mansour Khuja. I am a PhD student at Hasib Ben Bouali Ishlaf, and I'm going to present today author profiling from Modern Standard Arabic Text Review, written by me and Professor Morad Lokam and Professor Fatma Zahra Belkadim. So now we're going to go through the introduction to author profiling application, and why is it a challenge for research, related work and approaches, and future work and goals. Author profiling is a discipline in which people's written text is analyzed in an attempt to predict the demographic or personal characteristics of the author, such as his age group, gender, political affiliation, his mother language, his psychic characteristics, etc. Author profiling is considered as one of the most popular topics in research community in sight of its unlimited application, like crime investigation, security analysis, marketing analysis, historic literary text authorship verification, etc. Many works have been done in author profiling for many languages, mainly in English. For the modern Arabic language, author profiling may be considered as a new field. Unfortunately, there is a huge gap in Arabic preprocessing in the field of author profiling, and considerable amount of Arabic data is unstructured and need to be analyzed and processed. And this creates many challenges. So why is author profiling a challenge for research? The lack of resources and numerous levels of linguistic representation, phonology, orthography, morphology, and syntax in Arabic make it a very challenging but also a very appealing language to be studied. And one of the difficulties is the difficulty to extract personal characteristics from texts. For example, what is the author's gender, male or female? And can we extract this from the two texts below? I bought a handbag and I bought a book. From the first text, I bought a handbag, it is clear that the writer is a female author, because mostly women are those who buy handbags. But in the second text, I bought a book, it's there is quite ambiguity in it. It's not clear whether if it is a male author or a female author. The main procedures in author profiling are data preparation, text preprocessing to avoid overfitting, for example, punctuation elimination, such as the hashtag, the plus, the symbols, etc., which increase the dimensions of feature space, character set normalization, spelling normalization, normalize the hamza chair alif to alif, feature engineering, There are two types of feature engineering that have been considered to be the most important feature in text classification, which are content-based features and style-based features. Model training and evaluation. We need to train the prepared data in different models and classifiers to choose the model with the highest accuracy, both machine and deep learning. Since authors write in different styles and topics, and as the years goes by, styles and topics of the authors change as they get older. Therefore, these two features, style-based features and content-based features, play an essential role in author profiling. So as we see, the style feature that facilitates authorship profiling fall into four categories: lexical, syntactic, structural, and semantic. While among the content-based features, we can see the engrams, the term vectors, etc. Lexical features are also divided in two groups: word or character-based features. The lexical features based on words have properties like the number of total words, the number of words for every sentence, the distribution of the word length, and vocabulary richness. For example, if the words occur once or twice, etc. While character-based features contain character types, letters or numbers, the total number of letters for every sentence or for every word, etc. For instance, Estival et al. In 2007 worked on a system using a text attribution tool, and this system had been developed for the aim of extracting the author's profiles from Arabic and English emails. For each document, a feature vector was calculated: number of words, number of sentences. Other features are the frequency of punctuation, frequency of character, or word length. Also, Modersi addressed the task of author profiling at Penn competition in 2016 using stylistic and lexical feature extraction, engrams, punctuation features, etc. For the syntactic features, it indicates the pattern used to compose statements. They contain characteristics like function words, punctuation, and word roots. They are very useful to differentiate between authors. For example, it might seem that using the word thus or hence would cause no noticeable difference, but actually it can cause a huge stylistic difference. Argamon et al. In 2013 identified some simple classes of lexical features and some syntactic features, less than 50, where a huge difference was found between authors' gender when using pronouns and some of the noun modifiers, where female authors were more involved using these features. On the other hand, male authors were more informational. For the structural features, it contained text organizations and layouts, word structures, and technical structures. For word structures, we can see like number of paragraphs, number of points, spacing, greetings, signature, number of conversation sentences, words per sentence, number of special characters, context information, etc. While technical features such as font size and color size, they capture the additional information. They provide important insight into the writer's online style. Structural features were used in the work of Mina et al. 2013, where they described an approach for author profiling task using nearly 400 features, in which structural features were among them, in the form of number of conversation, paragraphs, sentences, and words per sentence, number of special characters, etc. Semantic features. They demand further analysis in linguistics and contain characteristics like synonyms, noun numbers, the aspects of the verb, the tense of the verb, etc. For For example, Barbieri et al. In 2014 presented a computational model able to detect sarcasm in the social network Twitter using 7 groups of features, among them synonyms, common versus rare synonym use, and ambiguity. Some of these features were designed to predict variance and surprisiness. Content-based features. Content-based features are words that are important within a specific topic domain, for example, like violence, sport, etc. Many content-based features has been explored. Among them, we can cite sentiment words, dictionary words, term vectors, informal words, and bag of words, etc. Due to the existence of dissimilarity in topics between different age groups and gender, using n-grams with different values of n, it can be possible to calculate the different frequencies of topics mentioned by the different author groups. For example, in blogs, topics such as football and computers are used more by male authors, while authors like shopping, husbands, other words are used by female authors. Sechler in 2006 used features that are based on style and content, both style and content, where for the content-based features were simple words based on content, special words extracted from linguistic inquiry and word count categories, and they concluded that females used involvedness in their writing, while male tend to information. We can also see that men were more concerned about technology and politics, and teenagers wrote more about their friends and mood swings. At the end, they concluded that the same features that discriminate between gender in writing style also discriminates between age in writing style, and they figured out that features based on content were slightly better than features based on style in age prediction. However, in gender prediction, combining both features proved to be more useful. As a conclusion, this presentation reviewed the state of the art of author profiling, particularly in the standard Arabic language. The main aim was to show what had been done in this field and highlight what should be done in the upcoming studies, and fill in the huge existing gap, especially for the Arabic in the field of author profiling. Thank you very much for listening.
Okay, thank you, Asma. Any question from the audience or suggestions to Asma? It would be nice if somebody talk and somebody asks. Okay, it's going to be passive, but fine. Any questions from the audience, please? Okay, well, okay, fine. So, Asma, are you still here?
Yes, I'm here.
Thank you. By the way, if possible, please, when you present, please turn on the video. Else, I'm gonna basically listen to the picture, right? I mean, at least for the sake of the, please, during the presentation, maybe at least I can just listen and also see your face, right? Okay. Anyway, can you just, open the slide again, please?
Yes. Okay. Share
yes.
Again.
A few questions. So the very first question is, so just to make sure that I understand correctly, basically your auto profiling basically to identify or differentiate between male and female, right?
No, not just male and female, also between gender and maybe political affiliation and so on. The related work, yes, I just in this presentation, just only in the presentation, I just used the gender and age group identification. That's it.
I see.
Yes, but because in the paper, I used others.
Yeah, yes. Actually, I don't know. Yes. I mean, I cannot access your paper. The point, I don't know.
Okay.
I cannot read. I don't know. I asked the actually co-moderator. I mean, can I access to the proceeding or lecture note?
What?
I mean, I mean, fine. I just asked the model. I mean, the co-moderator if I can access that.
The
Yes, sir.
presentation?
Yeah.
Okay.
A code.
Yes, sir.
Can I access to the paper?
Yes.
Or cannot?
Sorry, sir.
Can I access to the paper?
Yes, sir.
Can I have the paper?
Yes,
Or cannot?
yes, sir. Yes, sir. You can.
Look,
You can
how can I get the paper?
Via email.
Huh?
Through mail, sir. Email, sir.
I don't get the paper. I just get just as the schedule.
Right now, sir. You want?
I mean, have you ever sent me the paper or no?
Sorry, sir. I can't get your question.
Yeah, please send me. So I cannot. I have no idea. I just listen from the whatever I see. So sometimes, as I mean, Asma say that maybe some more work in the paper that she has no time to present, right? Yeah, and fine, but since I don't see the paper, but I assume the paper really may basically categorize what is the auto profiling, for example, gender and age or whatever, right?
Yes.
And I assume that you may have the table instead of I mean let's try in one paper by paper. You should basically summarize, right? Basically you can make a group. For example, if you classify you're profiling as the age, so what about the main feature of different papers, and what is the techniques, and actually I want to see the accuracy, right? What we want to see is basically the features and the techniques and the accuracy and limitation. And I don't know. I mean, the future. I don't know. Maybe it may have in the paper, but if it doesn't have, so it's nice to have that, right? Because when people take a look at the table, they understand clearly, right? I mean, many people work on this, and what about technique, feature, what a limitation of those, and then I mean, for people want to work on this area, basically just catch up the state of the art and go further. I think that's the key idea of the survey, right?
Yeah.
Okay, good. And one more thing, maybe what again is a similar question to the previous presenter.
Yeah.
What I think there is a auto profiling for the English language, right?
I'm doing auto profiling for Arabic language.
For the English language.
For English. What is the difference between the Arabic and the English language? Yeah. Okay.
Not different from the in the sense of what different, but in terms of profiling.
Yes. In terms of profile.
Yeah, in a sense, can we just apply the similar technique from the English auto profiling to the Arabic auto profiling?
Yes, but not very similar, because maybe Arabic is morphologically marked sometimes, like you don't need, like mostly Arabic is morphologically marked. Like you can understand, when you read the text in Arabic, you can understand the male and female because it is marked, you know?
Yeah,
it's not like in English. Yeah,
that is one thing. I mean, because assume we are not that good in Arabic. If you have example at the beginning, that will help our audience, right?
Yeah. Okay.
Just provide some example. For example, this sentence or that sentence, that is the key that make Arabic different and much difficult from the English, and the existing technique from the English cannot use. And I assume since you are PhD, you're not just doing the survey, right? Maybe you want to propose a new model, right?
Yes, of course.
Help, right? Help to propose a new algorithm in a sense, right? Yeah, I think it's very interesting, and I think the Arabic. I mean, a lot of people in the world use Arabic, right? And
yes, it's the most used language in the world.
Yeah, but again, I mean, we really need to have some that insight why we need, right? And what make different, and what is your key contribution. I mean, for the sake of your PhD graduation, not just this.
Yes.
Okay, thank
Okay.
you very much, Asma,
Thank you.
and hope we can see your new contribution for the high rank journals. Okay. Okay, thank you, Asma.
Thank you. Thank you.
I think the next presenter will be the Lamels Clark P. Well, let's go. Okay.
Yes, yes.
Thank you, and please go ahead.
I'll just share my screen. Okay. I hope so. You can see me and my screen. Hello?
Yeah, sure. Go ahead.
Okay. Good evening from the Philippines. I am Lemuel Clark Velasco from the Mindanao State University Iligan Institute of Technology, the premier research institute of science and mathematics here in MSU IIT in Southern Philippines. This time, I would like to present to you our ahead electric load forecasting using artificial neural networks. So I will be giving you the situation as the inspiration for this research. You see, load forecasting provide power utility companies with very good inputs for decision making. As you know, that electricity undergoes generation and then transmission, and then from transmission to distribution by power utility companies. This is why power utility companies will really need to predict and forecast the consumption of electricity in a particular locality, because undernomination will mean power shortage and curtailment to the geography that the power utility is serving, and overnomination will also result to surplus and excess of resources. That's why, as much as possible, power utility companies need to predict the optimal and the accepted load consumption in the locality that they are serving. So here you see the model that historical and current electric load uh, are existing among among power utility companies, whether it be a power utility company in the US, in Thailand, or in the Philippines. Power utility companies have access to this historical and current electric load, which they can use to develop electric load forecasting models. So they can use this historical model to develop a load forecasting model that they can use in turn to forecast different granularity, one of which are long-term forecasts. These are used for bilateral contracts and long-term contracts. Usually they are years ahead, or years the next year load consumption that they will buy among transmission companies, I mean among generators. And then there are also called medium-term forecasts that the power utility companies can forecast the month ahead consumption or to the week ahead consumption. Then the one in practice, they have short-term load forecast, by which the power utility company can predict the day ahead. So as you see, all of this long-term, medium-term, and short-term are used in practice to predict and to augment how what they can nominate and what the power utility can buy from generators and electric spot markets. Now there is a term that they call in practice, and this is more like a jargon, but it's a specific short-term load forecast, which is hour ahead, very short-term load forecast that the power utility companies will need as last-minute nomination to spot markets, just in case there are problems with long-term, medium-term, and the short-term load forecast. So here right now is the problem. There is a power utility company here in Southern Philippines, and they are nominating electricity to the market, to the electric market. Okay. And right now, they have a challenge on how they can nominate hour ahead, not month ahead, not week ahead, not day ahead, but hour ahead electric load forecasting that will in turn be acceptable to the 5% tolerance acceptable error, meaning to say this is the acceptable error of nomination and prediction by the power utility company, and the 3% tolerance error of the electric market in which they are participating. So they have two different standards that they need to predict as close as possible from the forecasted to the predicted. Now, this power utility company already has a year ahead load forecast. They also have a month ahead load forecast, long term, medium term, and they also have day ahead load forecasting systems. What they are lacking is hour ahead load forecast that they can augment just in case there are fluctuations within the activity of their locality. So the solution that this research wants to explore is to develop an hour ahead load forecasting software, simply because much of the researches and the literature review are focused on long term, medium term, and short term. Very few have really explored the hour ahead, simply because of the risk of simply because of of the nature of very short granularity. The way this was done is data preparation of the electricity load that the power utility has, and the implementation of an artificial neural network model, since much of the prediction model that they are using in their year ahead, months ahead, and weeks ahead, days ahead are on ANN. So we also want to explore ANN in their our ahead load forecast, and we will test if the model can comply with the acceptable tolerance error, 5% with that of the power utility company, and 3% with that of the electricity spot market by which they are nominating. So how did we do it? So we started with data preparation and was able to process 87,648 rows of 96 daily 15-minute observations of kilowatt delivered from 2012 to 2014. We used that 96, meaning to say out of the 24 hours, there are 4 each hour, since there is 15-minute observation. So that's 4 times 24. 96 daily 15-minute observation, and we tried to use the kilowatt delivered simply because this is the load consumption. So we were given the date, the time, as you can see, per 15-minute observation, a total of 87,648 rows. And then data cleaning was performed to the 3 metering points, since there were 3 metering points before it was aggregated to the total consumed load of the city by which the power utility is serving. Another is that since it's artificial neural networks, we used min-max normalization to transform the data from 0 to 1. So we used min-max normalization, and we conducted data partitioning in preparation for the artificial neural networks. There were 83,267 rows that were used as a training set, 2,629 rows that was used as the testing set, and 1,753 rows that was used as the validation set. So what did we find out? What were the results of the data preparation? Now, I'm showing you right now the electric load data plot that we had for 3 years. So this is how erratic and systematic the load consumption of the city based on the data from the power utility companies. So there were 2,263 rows, or about very few, 2.2% of the entire data set that contains zeros. Zero, why do you think it is zero? Simply because we found out in the data preparation that these zeros will really do not mean within the metering point, they really do not mean that metering point or the consumers did not consume electricity. It means that there was power outage and power interruption. So had there been no power interruption or power curtailment, it would not have been zero. So this needs to be corrected, and this needs to be prepared and cleaned, simply because this is erratic. This is an anomaly, and there has to be data preparation that should be conducted to this, because it could potentially throw off the results of the network. Okay, so how this was done, and so the only issue that we had was the zeros, which meant the curtailment or the power interruption. So for example, in this case, we had this from 9 to 9:30, we had zeros there, which again do not really mean that there is no consumption. It just means that there's power curtailment, power interruption. So what we did based on related literature is that we referred on the same time spot on the preceding, from the preceding day, and get the time spot of the succeeding day, and got the average of that, and eventually replaced that with the zero consumption, meaning power interruption. A lot of the most of the most of the most of the most of the literature have different methodologies, and we use this simply because this, I think, this we think is the most optimal for this situation. Data replacement. So this is what it will look like from the original data if there is a power curtailment and there is a cleaned data, and it will look like this. And again, the methodology is that the preceding electric load consumption and the succeeding will be getting the average, and it be eventually replaced just for it to have a normal usage of electricity instead of having this as an anomaly. So we also conducted data transformation, and it looks like this. So there is raw electric load, there's a day of the week, okay, weekend or weekday indicator, because much of the load consumption of a particular locality will change if it's weekend or if it's weekday. It also matters what the day of the week, from Monday to Friday, that type of day, if it's holiday or normal day, the week number of within the year, the time span from 1 to 96, because there are prime time usage of electricity compared to dawn, and then the day, or the date, the month by which it has, and the year. So how this is what it looks like after data normalization using mean max normalization as a result. So another methodology is that after conducting the data preparation, we will need to implement an artificial neural networks model. So what we did is that we used 9 input neurons, the 15-minute load, the day of the week, there is a weekend or weekday indicator, and this is based on literature. The type of the day, whether it's a holiday or not, the week number, the time, the day, the month, and the year. So the day is different from the day of the week, because the day of the week is from Monday to Sunday. The day is the date. Okay. So we had 2 training algorithms used: resilient propagation and quick propagation, and 1 activation function, sigmoid, that will be eventually, after training and testing, be used to predict the next 15-minute load. So it's the next 15-minute load that it will predict for our ahead load forecast. So the implementation looks like this. We use a multi-layer perceptron neural network, which has a feed-forward type of architecture for the neural network. There were 9 input neurons used, 6 hidden neurons, and 1 output neuron, which is the next 15-minute load. We set the learning rate to 0.00001, set the momentum to 0.7, and had an epoch value of 20,000, as well as the maximum error of 0.001. And then we implemented it, that the system should be able to import the data. It should be able to train the network, evaluate the network or test the network, and predict the network. And this is what it looked like. when it was used. So as a result, what was the result? Since we need to compare the predicted and the actual results. On the first model, which used quick propagation training algorithm and sigmoid activation function, as you can see, this is the comparison. The red is the actual out of the load of the validation set. The red is the actual, and the blue is actually the predicted. So you can see that there is following there, and it was able to generate 2.91% of mean absolute percentage error, meaning to say that's 2.91 deviation from the actual to the predicted within the validation set. So this is acceptable, both by the tolerance error of 5% by the power utility company, and the 3% tolerance error of the electricity spot market that I presented. On the other hand, the resilient propagation and sigmoid activation function, and this is what it looked like. The red is the actual again, and the blue is the predicted for 15-minute interval, and this one is the load consumption, which had 3.49% of mean absolute percentage error. It passed the 5% tolerance error, which is the international accepted tolerance error for electricity load forecast, but it did not meet the tolerance error for the electricity spot market. So this quick propagation and segment activation function was more promising indeed compared to that, but both of them really had very promising load forecast. So what can we conclude out of this? This research was able to show that it's really possible to develop hour ahead load forecast as a supplement to that of year ahead, month ahead, week ahead, and day ahead load forecast. We were also, through this research, it also shows that artificial neural network still has the has the potential to really predict close to accurate load forecasts, which really reaches the acceptable tolerance error for this particular situation. So that's our ahead electric load forecasting using artificial neural networks. This I hope if ever you're interested after the questions, you can email me through this. You can scan the QR code and you can hit me a personal email. I'm very interested if you have questions on our study.
Thank you, Lamel. I'm sorry if I call the first name. I'm not sure for the US we call last name, but I'm not so sure in general. But anyway, let me basically call your name in the first name. Sorry if it's not anyway. Okay, and it's interesting. It's very useful. To me, but some question come to my mind. I think this problem has been researched for years, right? I just wonder any other techniques, that do similar way to you. Do you do any survey before that other may propose something and it's not good?
You see, Dr. Chakshai, the challenge actually artificial neural networks, again, as I've said in my introduction, has been used much on load forecast, specifically on day ahead, that of short-term load forecast and medium-term load forecast, week ahead and month ahead. Its performance, doctor, for the very short term, the hour ahead, is really not that promising. If you will go over the literature, the one that's promising really for the short-term load forecast is support vector regression machines,
Right,
SVM.
right.
So simply because it's very short term, and the challenge of loading it right away and adding it up to the model that it can learn, and how you can train that. So this research, you are right when you said that there are a lot of existing, there are really a lot of existing researches that explored on medium term and short term load forecast. But if we can go over the very short-term load forecast, the hour ahead, artificial neural networks still has a lot of challenge in dealing with the very short-term granularity of forecast. So I hope that answers your question. There are still
Yeah,
gaps.
but maybe I mean it can basically make us convincing if you basically make a comparison with others, right? And then you just show that your proposed method is better, and also digging in the key inside of what you claim is in the very short term you are better. I mean that is basically make the audience understood, right? So anyway, so fine. And a quick question, a few more questions. So what is your the length of the data set? How many years that you use for this test bed?
So we actually use 3 years only of historical low data, and 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 if you can go over a lot of researches, especially if it's neural network, it's usually longer and longitudinal in nature. We just started with we really tried to explore if it's three, if it is possible, and we were able to show that it's possible.
So have you also observed in what let's see what kind of data that make the error? Because you said that there are some percent, right? That you can achieve 100%. Have you also dig inside? What make that? What made your models? Inaccurate.
What we have, what we have observed usually on feed forward neural network, and this has been asked also in the question I will answer. This has to do with the question, sir, that someone in a question asked if I have considered to embed more hidden layers to your model or use techniques for further reduce the residuals obtained from the neural networks. We tried to use six hidden neurons in just one layer, simply because we would try much of what they used in their power utility company is just feed forward neural network with single layers each. So we tried to, as much as possible, have that aligned to what they have, that they will all use multi-layer perceptron neural network and feed forward our architecture with single layers each. That's why we had the opportunity to really explore if it's really just possible to use the.
That's fine. But I just if you can basically find the reason why you cannot meet 100%. That is very good motivation to more work in the future, anyways, right? So
Exactly, sir. We will. I will. For future work, we are really trying to dig deeper into that. But what's funny is that most artificial neural network still has a lot of retooling and and upscaling to be done, especially on very short term load forecast. But we can surely improve on that.
yeah, because for example, I'm not sure, but uh, if I just my guess, right? If we observe for over 3 years, normally it's not just a power outage, but some events. For example, for example, if in Philippines let's suppose you will hold the Olympic, for example, some big events or whatever that will make the people use the energy. And if you take that into account, your prediction will fail. My point. If you, understand your data set, then you can cut out at the outliner and just don't add it into the, just a normal living, right? Because we want to basically forecast what is the in general, right? But if you can cut out of those, big event or whatever, I don't know. Then maybe your accuracy may be higher. That is my point, right?
Yes, yeah.
If you understand the data that you know, then you can explain clearly, and I believe that the accuracy will be higher. That's it. This is what I think.
Yes, thank you very much for that input. We'll
Yeah.
sure consider that.
Okay, sorry, I mean, I asked first, but anyway, any question from the audience? Because I think it's very useful, and this is basically one of the purpose of the smart grid, right? We have the smart grid, we want to balance the energy, and actually we can rerouting the energy here, the power here too. But are we looking for to see you? I mean, I use it in the industry. I don't know if the industry use also the ANN for the forecasting too.
We much of the industry, much by survey here in, especially in southern Philippines, a lot of power utility companies are just using linear regressions.
I see.
More of the statistical. That's why this is something new for them to use artificial neural networks, because they've been using a lot of linear regression on their load forecast.
Okay. And any question from the audience? Okay, and else, I mean, thank you again, Lamel, and it's very good. I mean, good work. I mean, hope to see you. I mean, in the real industry anyway. Okay. So the next presenter will be Native Singh. And I'm sorry if I pronounce it not correctly. Native Singh. Okay, please. Please turn on your, I think your microphone.
Yeah, am I audible now? Am I audible?
Yeah, you are good. Yeah, please.
All right. Let me share my screen. Yeah. Good evening, participants. I'm Navtej Singh from India, and I'm going to present a paper on performance analysis and comparison of our classification algorithms for EEG-based BCS system. Now, this is a very interesting application of machine learning and artificial intelligence, wherein we can establish a direct communication pathway between a human brain and some external devices. And as you can have a look at this, the application of this is really interesting because we can provide some kind of rehabilitation to people suffering from motor disorders. And as far as this signal processing is concerned, we acquire the signal, pre-process it, feature extract it, and then classify. And then there is an application interface which is fed to some applications. This has been gaining popularity in recent years because it has ability to improve the life of people suffering from motor impairments, and also it can also be used for some other entertainment purposes besides this very critical application in which the patient suffering from neuro disability they can kind of be rehabilitated. This is an evolving technology, and this reads electrical signals directly from the brain, and then the signals are translated into digital form. Now, this is the core concept of this whole setup, that MI is a mental stimulation corresponding to imagining a motor act without its actual and physical execution. This is based on hypothesis that whenever a person is trying to make some motor activities like lifting the left hand, right hand, feet, or tongue, etc., it leads to some changes in localized EEG across the human brain, and that can be fetched from the scalp by placing some EEG nodes. Now, again speaking, please understand that this EEG processing and EEG data fetching is now limited only to about 4 or 5, rather 4, I would say. In my study, we used only 4 kind of different movements, and that's a left hand, right hand, feet, or tongue. And there are only 1 feet movement without the distinction between left and right feet. The reason, because left and right hand movements are easily differentiated, whereas left or right feet movements are not easily distinguished. So the difference is not very loud, so leads to problems. So basically we are restricting ourselves to left and right hand, feet, and tongue movements. Now, EEG signals, these can be fetched by placing electrodes on the outer surface of the scalp, and this is a non-invasive way. Alternative to this, there could be some invasive ways also to fetch these signals, but they require some surgical intervention, so not advised. Now, in this objective of this proposed research, what we are trying to do is we are trying to investigate some existing feature extraction and classification techniques. We have seen in a previous slide that feature extraction and classification are important stages in signal processing. And to analyze and apply these pre-processing, some techniques or pre-processing techniques are applied before we can apply extraction and classification technique. And then we will validate and test using some confusion metrics, the results of different techniques. And the data set, which is nowadays a standard being used, is dataset 2A. It is provided by Graz University Austria in BCA Competition 4. And this dataset is used to validate processing classification methods or BCI. Now, essentially, this dataset relieves the researchers from dealing with actual physical data collection by applying EEG signals electrodes on the brain or scalp of the person. And this is a ready-made data set which is available. This is openly accessible and high quality neuroscientific data. In this, a typical subject is asked to stay focused, have a look at the screen for about 8 seconds, and different beeps are there after 2 seconds, then 3 to 6 seconds is the actual imagining a movement, whether it is left hand, right hand, feet, or tongue. Then there is a break, and then again the person is required to repeat this as per the. So this is what we are doing while the person is performing this imagination between 3 to 6 seconds. The data set is fetched from the different electrodes placed. So there are 25 channels used in this data set. And the calibration session, there are two sessions, calibration and evaluation session. A calibration session includes performance of the 4 of the motor imagery tasks, which I just explained. And these 4 actions are happening as per a cues on the screen in the front of the chair. There are 9 subjects involved in this. 2 sessions on different days are recorded, and 1 run consists of 48 trials, is yielding 288 trials per session. And methodology we are using over here is we are using BCA Lab, which is a MATLAB toolbox, and EEG Lab plugin for the design, prototyping, testing, and experimentation with BCA. The toolbox has been developed by ICICT at the Schwartz Center. Now, different stages in the signal processing. The first stage is to pre-process and remove artifacts. The EEG data fetched has got a lot of noise. One of the primary source of the noise is 50 to 60 hertz power line interference, then baseline drift, and other biological signals happening from the body. And these signals, like say for our heart is like pumping, and some other muscular actions are happening all the time. So their signals are also interfering with the signals which we are trying to fetch from our scalp. And for this, we use different kinds of algorithms. For example, CSP, that is common spectral spectrum, PCA, and ICA are popularly used in pre-processing stage to reduce these noise signals. And in subsequent slides, I'll show you what kind of algorithms we have used and the results we have attained in this. And then feature extraction is a process of reducing the raw data to accomplish pattern recognition. And the most distinguishing features from EEG signals have to be extracted by the classification in next stage. Now, since the data is huge, this large set of data is very difficult, so we extract only the corresponding features from the huge data which we got. And then we select few features from this extraction by analysis of EEG. And feature extraction is a kind of a process of transformation of one or multiple signals to a single feature vector. The selected and extraction of good features improve the performance of the system. So this is before we actually start classifying, we extract some features and then we select some features. Then classification. It executes a classification algorithm to model the selected CSP features and classify it into AMI classes. The class identified by the type of mental task performed by the BCI. Basically, what we're trying to do over here is, by making an analysis of the selected features, we are trying to assign a class to this. So we expecting 4 classes, as I said: left hand, right hand, feet, and tongue movement. So these are some classification algorithms which we have considered. First one was the LDA. It classifies a record of set of observation into pre-configured classes. This is the objective of this. And it executes linear transformation of data from that of high dimensionality space to a low dimensional space. And it basically establishes a hyperplane and linear combination of features which can successfully then demarcate multiple classes. It's got lower computational requirements as compared to some other alternatives. And we can use SVM, Sport Vector Machine. This is a very popular one. So this classification algorithm, which uses discriminant hyperplane for performing distinction between many classes. And the hyperplane is selected in such a way that which calculates the distance from the closest training point. And it can also make use of some parameters for regulation that provide it a tolerance to outliers and inbuilt errors on the training set. Then got a nearest neighbor classifier. So it is a supervised learning algorithm which has the capacity to store available case scenarios of signals and the classes. So it makes a comparison of training data with that of the featured value of the testing data. The object is allocated a class which it shares with k neighbors. Then there is a naive-based probability. This is it allocates a class to the selected features based upon its description by feature vector. It's a simple method to establish classifiers which assume independence between different features. Then there are neural networks. It's inspired by biological nervous system. Method has some internal parameters, and it makes use of multi-layered perceptron, which is a collection of many layers of neurons. So next slide will make a comparison. So um, we got 3 categories of subjects: K3, which we named as a K3, K6, and L1, having varying degree of experience in BCI training. So basically, we are making a comparison of 2 pre-processing methods of CSP and AAR. And we have applied LDA, NNC, and SVM classifiers to evaluate their performance. So this is the results which we got. The classification accuracy, as you can figure out, in the experienced BCI users, it is as expected, it is on the high side as compared to the beginner and even the less experienced BCI users. So we assume that a person who is experienced in using a BCI, just like a voice recognition system, so there is a high probability for these classification algorithms to work. And in this, we have used CSP used to pre-process. And then we tried using AAR method. And then we, again, it's on the expected line. However, the performance is less as compared to when we use CSP as pre-process the method, as a pre-processing method. And otherwise, experienced users are better equipped to successfully classify the selected EEG signals. Applications of BCI. The basic application of all this is medical rehabilitation, but however, it can be used in some entertainment, and we can use it in robotics and offering limitless potential to some other technologies. This technology can be used in some many other ways besides the medical rehabilitation. What we tried to make a comparison of different classification methods and figured out how they're going to behave, what kind of results they're going to give in feature extraction, selection, and classification methods. Because the more efficient algorithms, if are applied at different stages, then it is going to lead to the more robust and an efficient EEG-based brain-computer interface system. And in the future scope, the proposed study can be verified in some real-life scenario to ascertain its reliability. Right. Thank you. Can I have some questions, please?
Thank you, Mr. Singh. And any question from the participants, audience? I think it's a very interesting work, right? So any questions, suggestions, or whatever? Or I mean, if you have suggestion or questions, just chat, right? I mean, people like chat, so just chat. So I can just read it. Anyway, actually, I also have some question because I personally, I mean, worked on this area 5 years ago. Uh, the accuracy mostly depend on the experience of the user. We need to train him a lot,
Yep.
right? But in the actual, can you, I mean, provide some example of the actual, I mean, possible application? Because in the real world, so example, if let's suppose if you want, I mean, the very, I mean, so far futures, if you want to make the, I see the human drive the car automatically, I mean, for example, right?
Yeah.
That case, I mean, they are all beginners, and
So it's just
they are.
like since this is an international conference, many people are maybe having a problem like making sense out of my maybe accent. But however, my students or my colleagues, they don't face a problem because they're been like kind of tutored or they've been trained to listen to my accent, and similarly like the vice versa, otherwise also, right? So the more experience, so even like let's understand like voice recognition system. So some couple of years back, like we used to speak some 100 or 1,000 words through a kind of a software before it could make sense what like a person is trying to speak. So the same kind of a holds true over here, and more experienced user would be able to more kind of focus for calibrating his or her brain computer interface.
Yeah, to me, it seems that we may be, I mean, we may focus on the beginner or non-experience because there is a room, right? There is a huge room to improve to get a high accuracy.
That's right.
Actually, something come into my mind. For example, I just want to develop some protocol or some uh, and something that can basically help the beginner to stay focused and sell basically. Right? I just basically have something to make sure that they are concentrated, and then they can.
Akurat o tym PCI mówił, wiesz, tylko taką bardzo miał podstawową prezentację.
I'm not sure. Okay, I'm sorry. I don't know what's that. But anyway, I think it's good, and it's some room for the beginner because for the trained experience. I mean that for the experienced BCI, maybe they may be used in the hospital or whatever. But there are big room because based on your graph, right? Can you go back to your performance analysis? Yeah, I mean the previous one. Here. So here, I mean, it's obvious that this CSP is good, right? But there is a big room for the beginner and the rest, right? And actually, it can.
We should try to like optimize these parameters.
Yes,
and we should not focus on experienced BCI users. However, focus
you
more
can
on
do, but
doesn't
affect much, right? Okay. And also, I think there are a lot of noise. I mean, if you can get rid of noise, and then or I don't know, find some protocol to have them concentrate. I mean, else you can just have to focus on your algorithm wise, right? Can you go to the next page, next slide? It's a little bit, I mean, confusing here because you see, the beginner is better than the experience.
That's right, because like the pre-processing method used in this case was AAR, and the overall performance is not really good in this. Like when we use AAR to pre-process it, so if you can like just like make a comparison with this CSP when CSP is used to pre-process.
But
I just wanted this kind of
double check. Then I'm not sure, right? To me, maybe I'm not sure, but you should double check. the result. It shouldn't be that. But anyway, I think it's good, and I think it's almost. I think it's very good. I mean, paper, but you can enhance a bit. Just propose the new algorithm. That
Okay.
will be very good, right? This basically you are doing a very good job for the survey, right? And
Right.
you the actual implementation, that is very good because you can show the performance. But if you can point out the key contribution, say propose the new way of the pre-processing or hybrid way of the classification, and actually you can just apply the deep learning to me.
Yeah. No
But
problem.
anyway, right? I mean, you can get the paper, a very good paper. I mean, out of that, right?
Thank you.
Yeah, and anyway, so based on your, I mean, experiments, can you tell us some experience? I mean, what is your obstacle, or why is what part is so difficult? So you can share to others if they may interest in your work.
See, basically, this whole results is based on a simulation, actually, as of now, right? Um, the real because the data set which is being used in this case is kind of a ready-made data set, and because it needs a lot of medical expertise, and this is one bottleneck. Like we, if to fetch the data and um, algorithms, yeah, we have to optimize the algorithms maybe based on the personal traits of the user. We can figure out some parameters. That's what I'm trying to work on now. That every user will have a different kind of parameters which can be set,
Yeah,
and
yeah.
yeah, so that will help the beginners maybe. Yeah.
Yeah, because I did actually measure the actual ECG,
Mhm.
and there are some a lot of, I mean, the variations, even with the, I mean, gender,
Yeah, that's
age,
right.
and activity before they sit here. I mean, the emotions. I mean, a lot of, I mean, thing that affects, right? And I think you can see a lot of interesting point when you attach that with. I think recently, I mean, that equipment is not that, I mean, costly, right? And I think in the future, if you continue this, I think it's very good, but still, right? Yeah,
Right.
very
Thank you.
good. Thank you. I mean, any question from the participants? Else, thank you again,
Thank you.
Mr. Singh. And let's move on to the next presenters, Mr. Mustafa Al Jendi.
Yes, hello, I'm here. Just a moment to share the screen. Can you see my screen now?
Yeah, sure.
Loud and clear.
Okay, hello everyone. At first, I want to thank you for giving me just the chance to present my paper. My name is Mustafa Al-Jendi. I am a PhD student at University of Pannonia. Today, I'll talk about helping people with visual impairment to avoid obstacles using deep learning techniques. So this is my agenda: introduction, related work, scientific work, and the results. And finally, I will summarize my results. Nowadays, there are more than 200 million of visually impaired all over the world, and this number is expected to increase. As shown in the figure, it is expected to be more than 500 million people at 2050. People with visual impairment face a lot of problem in doing daily activity in outdoor places, suppose a trip to a doctor or walking in a known environment. And it's also the same for indoor places. Can you imagine if a BVI is in a hospital or in a shopping mall and he want to go to a specific location? This problem makes them always need help from others, like family, friends, and also makes them use traditional technique like guided dogs and white cans. And also this problem preventing them from being active and socially included. So researchers try to find solution for outdoor navigation using GPS technologies. However, this GPS technologies is not suitable for indoor places, as the satellite signal are scattered by wall and object inside the building. So researchers try to find other solutions, like using tags such as NFC tags or RFID tags. Some researchers use computer vision and deep learning techniques. In my research, I concentrated on using computer vision and deep learning techniques. My goal was to implement an indoor navigation system to help BVI navigating and avoiding obstacles using computer vision and deep learning. I put two main components. The first component, how to navigate from a starting point to destination. The second point, how to avoid obstacles during navigation. For the first part, I built a navigation system with the following architecture, as shown in the figure. It consists of three main components. The first one is markers. The second one is a map storage database. And the third one is a navigation application using by BVI. For the markers, at first, a sighted person should go through the building to identify interest points like labs and the lecturer rooms. And after identifying these points, markers are printed and installed at this interest point. As shown in this figure, this is a blueprint of the building at University of Pannonia, and the red circle represents the interesting points. After installing markers, we have to build a database to store these markers. To build this database, we use the graph. Nodes in this graph represents the interest points, while edges represents the connection between these points and the number of steps. As shown in the figure, this is the graph for the same building. As you can see, the circles are the interest points, and the edges represents the number of steps between these points. After building this graph, I have stored it in a database to be used by the navigation application. And to store this graph in a database, I used an admin application to build the edges and the nodes and the connection between them. For the navigation system or for the navigation application, to start, the application need to know the starting point and the destination point. To find the starting point, the application starts by opening the camera and try to find a marker near the BVI to be used as a starting point. After that, the application asks the BVI to select the destination using voice commands. Then, after identifying the starting point and the destination point, the application tries to find the shortest path between the starting point and the destination point using the Dijkstra algorithm. During navigation, a continuous feedback is given to the BVI to go from one point to the next. As shown in the figure, if the BVI is standing at point 1, and he asks the application to go to point 5, which is the destination point, the application finds the shortest path between point 1 and point 5 and tells the BVI that to go to point 5, BVI should go from point 1 to point 7, and then from 7 to point 6, and finally go from 6 to point 5. During navigation, a continuous feedback is given to BVI to help him or her to reach the destination point successfully. However, this is a screenshot of testing this application by blindfolded and by BVI in the same building of the university. However, there are some problems for this system, that markers can't be detected from long distances, and also blaring effects due to motion, and if there is a part of a marker is occluded. For the second part of our system is to detect obstacles. I try to build an application to avoid obstacles using deep learning, using YOLO version 3 model. And as shown in the figure, this is the flowchart of this application. The application starts by opening the camera to get a live stream of images. And then these images are converted to a grayscale and is given as an input to the model. If the model detects any obstacle, a feedback is given to the BVI. However, if it fails to detect any obstacle, it continues with the next image. I trained the YOLO version 3 model and a simplified model of it called Tiny YOLO version 3 model. I trained both of them and compared both of them. I used a data set for only 5 classes, which represent the most important classes inside the buildings, like chairs, desks, doors, stairs, and people. I used 10,000 images for training, 2,000 images for validation, and 500 images for testing. The result shows that the object detection accuracy for YOLO version 3 model is 94%, while 52% for the tiny YOLO version 3 model. And it gives also accuracy, recognition accuracy, 97% for the original YOLO version 3 model, while it gives 95% for the tiny model. From these results, I use the YOLO version 3 model for our system. However, the execution time for the tiny YOLO version 3 model is better than the YOLO version 3 model, as it can detect object in about 3 milliseconds using GPU. However, the original model takes 9 milliseconds using GPU, and it takes about 250 milliseconds for the tiny model and 2 seconds for the original YOLO version 3 model using a mobile or CPU. From these results, I found that I already used YOLO version 3 model, but the execution time should be minimized. I have to try other algorithms, or I have to run this model on any hardware like Raspberry Pi, Intel NCSS. Also, there is another problem in this system. It can detect the object easily, but it can't calculate the distance between the BVI and this object. So we have to use some sensor like ultrasonic sensor to calculate the distance. Also, in this system, we use only five objects as a sample. So we need to add more objects to our data set. And also we have to integrate the obstacle detection with the navigation system. To summarize, I have built an indoor navigation system to help BVI navigating indoor, and I have tested it by blindfolded people and by BVI. I have already built an application to detect and avoid obstacles using YOLO version 3 model, and I just need to integrate both of them together. Thank you for your attention.
Okay, thank you, Mustafa. And please, from participant audience, any questions, suggestions, or share some experience that will be helpful for this conference. Okay, else okay, it seems to be my job to ask the questions. Okay, fine. But actually it's interesting, and also I used to work on this area 7 years ago. Yeah, once we don't have deep learning, the key actually, what I say, the most difficult thing is to test with the real blind.
Yeah.
It's very different when you use just the human with the blindfold and the real blind.
Yes.
They walk differently, and yes, and yeah, believe me, I mean, I don't know if you test is the real blind yet, but when you work with the real blind, a lot of things.
Yes, you are right. Yes, yes. At first, I have tested it by blindfolded people, and when I try to test it by BVI, I face some problem like the walking distance.
Yeah.
BVI walking is slower than the normal people, and also walking in a different way. So I have tested it by BVI and got a lot of feedbacks and update the software based on these feedbacks.
Yeah, and I asked my student to do that, and actually the blind say that can they just use the old way of the it's difficult to ask them to trust us, but anyway, 5 is very good. And let's see to my let's go back. I come back to your contributions. I'm not sure, but about the marker, because so what kind of marker do you use? The FCIVD or the what is that?
I used a type of marker called Aruku marker. It's a square marker.
No, what I mean is like they use the or just the marker like a QR or the QR code like that.
Yes, it's just like a QR code, but it's more accurate than QR code. It
Yeah,
can be
but that's what
detected.
but you cannot detect the distance then.
For the Aruku marker, I can calculate the distance, but for obstacles, I can't calculate the distance till now.
I'm confused. How can you detect? How can you calculate the distance based on?
For Aruku marker, which is used for navigation, when any Aruku marker is detected, I can calculate it because at first we make a camera calibration, and after that, during navigation, if any marker is detected, I can calculate the distance to this marker.
So how precise is?
Sorry again.
How precise is? Because actually, I mean, when I basically use the Bluetooth. We calculate the signal, so we can get the quite accurate distance. I'm not sure that when you use the camera, the image, I mean, how precise it is.
When we already tested it, we found that it's accurate, and the calculated distance is near to the real distance.
I see. So what about the effect of the dark at night?
I can't hear. Can you?
For example, the day and night. I mean, because you all use the image, right?
Yes, for our system, at first we tested it on daily, but if it used on night, we can use the flash of the camera.
Okay, I'm not sure,
but it's hard to be used at night. It's mainly used. I already tested it during in the morning, in the afternoon, but I haven't tested it at night because it will be dark and it can be used inside the building if there is any light.
Yeah, I see. Okay, and I'm not sure, but because you just try to classify just a 5 object, right? And in the actual building, do you have only 5 objects?
I just used 5 as a sample at first. Now we are working to add more objects which are already inside the buildings. We try to add more objects to this system.
Yeah. Okay. What about? I think the static object is okay. I mean, not difficult to detect, and I think the deep can basically work with that. But about a moving object, like a person?
Yeah, like a person. Yes. This is a problem because we can detect till now we can detect the people or moving object, but we can't calculate the distance. So maybe we can detect it more near or far. We don't know. So I just have to add some sensor like ultrasonic sensor to calculate the distance. So BVI can can take care of that. That there is, for example, a person in about 2 meters or 3 meters.
Okay, I see. Yeah, good. Can you go back to your performance analysis? I mean the table. I
Yes.
just have a quick question. But anyway, I don't have paper. Just try to guess from what I can remember. So here I'm confused when you can see that the tiny YOLO, I mean YOLO 3, the tiny one, the detection accuracy and the recognition accuracy is very low. But then in the last column, the the recognition is high. I'm a bit confused.
The detection accuracy means that if I can detect object or not. Recognition accuracy means here if I detect object, can I detect it correctly or incorrectly?
So can you just, I mean, give some insight? Why is that? It's quite, I mean, I'm not sure.
For example, if I detect a door by the simplified model, it gives 94% that it is correct a door, not a table or a chair. But sometimes I can't detect that there is a door or a chair. This means the difference between the detection and the recognition accuracy.
No, yes, I know, but can you just give some insight why the tiny one is so low in terms of accuracy and of the detection than the recognitions?
I found that the tiny model is lower than the original model because it has less layers than the original. It contains about 30 layers, as I remember, while the original model contained about 90 layers. Or that's why it gives more accuracy than the tiny model.
Okay, but it's worth to investigate because the detection is low and the recognition is high. Yeah, I don't know. It's just I'm thinking about that anyway. Okay. Thank you very much, Mustafa, and hope to see your work. I mean, in the future.
Thank you.
Okay. Thank you.
Thank you so much.
Let's move to the next presenters. Nasrat Nasrat, if I pronounce correctly.
Yes. Can you hear me, dear Rajan?
Yeah, sure.
Okay. Please, just a minute. I will share my screen. Can you see my screen, dear Rajan?
Yes.
In the name of Allah, the most compassionate, the most merciful. Our work title is Implementing Predictive Model for Child Mortality in Afghanistan. Authors are me, Nasratullah Nasrat, and Associate Professor Dr. Kitichai Lavangnanda, School of Information Technology, King Mangoots, University of Technology, Thunburi, Bangkok, Thailand. Outline of the work is background, problem statement and motivation, related work, methodology, results and discussion, and finally conclusion. Child mortality is a core indicator of child health and well-being. Improving child health and reducing child mortality rate are key health priorities in underdeveloped and developing countries like Afghanistan. I want to see something about the child mortality rate. The rate of child mortality is the number of deaths among the children under the age of 5 years per 1,000 live births. In 2000, world leaders agreed on the Millennium Development Goal 4 to reduce the child mortality rate by 2/3 between 1990 and 2015. Between these years, from 1990 to 2015, the global child mortality rate has fallen from 91 deaths to 43 around the globe. So the Sustainable Development Goals sets specific target to reduce the global child mortality rate to 25 deaths by 2030. As we know, Afghanistan is underdeveloped country. Afghan people have been suffering from 4 decades of civilian wars, instability, political situation. The country has the highest rank of maternal mortality around the globe. Hence, the rate of child mortality in Afghanistan is also high. Predicting child mortality using up-to-date computational tools is a potential forward step in Afghanistan. Highly trained and skilled physicians are very scarce in Afghanistan. Equipping health facility and health professionals with such a predictive model for investigating the likelihood of child mortality is essential for reducing child mortality rate in Afghanistan. It can also help physicians augment their actions to educate mothers and take preventive measures of their children to reduce child mortality around the country. This is the problem statement and motivation. As I said before, child mortality is a serious global health issue. It's remained in a critical situation in Afghanistan. We can say per thousand of babies born, 60 will die before the age of 5 years in our country, Afghanistan. Poverty, short preceding birth interval, low level of education, especially female mothers, lack of clinical services, not breastfeeding, unsafe drinking water and sanitations are the key factors leading to child mortality in Afghanistan. So this study aims to build a predictive model for child mortality in Afghanistan and also identify the most suitable classifier among the well-known machine learning techniques. Also, the predictive model can help physicians and doctors to counsel potential risk factors of childhood mortality and provide an option to predict child mortality, which can be used as an early warning to identify children who are at risk of dying. Our related work has 2 sections. The first section focuses on determinants of child mortality. We can see here, there are different countries, study and work from different countries, Bangladesh, Sri Lanka, Pakistan, and also Afghanistan. The study results found different determinants of child mortality, like breastfeeding, age of mother at birth, birth interval, and etc. These are the determinants of child mortality, which is the result from different studies in different countries. The second section and the second part of our related work focus on determining applications in healthcare. We can see here HIV detection system. They applied different determining techniques, random tree, G4H, neural network, and logistic regression. As a result, random tree outperformed with highest accuracy of 96%. For malnutrition detection, also random forest and CART performed well among other algorithms. In case of child mortality, G4H, another child mortality, random forest, and finally for breastfeeding classification, G4H performed well among other classification algorithms. This is the overall methodology of our work. The classifying task in this study is binary classification. The data set is divided into 2 categories, alive category and dead category. Alive category comprises mothers whose child was alive during the survey, and dead category indicates children's whose child was dead during the survey. We can see this is our AFDHS dataset. We use AFDHS dataset, Afghanistan Demographic and Health Survey dataset, which is collected data in 2015 from Central Statistical Organization and the Ministry of Public Health of Afghanistan. After that, we do data pre-processing. In data pre-processing, we have 2 steps, data cleansing and feature selection. Totally, AFDHS dataset has 32,712 records. Some records have missing values. For this reason, we do data cleansing. After data cleansing, 9,000 records, complete records are available for further analysis. In feature selection is the process for selecting significant feature and attributes for the task at hand. FDHS dataset totally have 1187 attributes. In feature selection, we use C-based correlation-based feature selection technique, which has an ability to handle both numerical and categorical attributes. We also have some vigorous discussions with domain experts and doctors for selecting good and significant features for the study. After that, we have data mining. We divide original data set into trend set and test set. The ratio between the trend set and the test set is 80-20. For the implementation of the predictive models, we use 5 well-known classification algorithms: k-nearest neighbors, random forest, new Bayes, neural network, and support vector machine. After implementation of the classifiers, we evaluate the performance of the predictive models. We use common evaluation metrics: accuracy, precision, recall, and area under the RAG curve. Finally, we develop a predictive model for child mortality in Afghanistan. Yeah, as I mentioned before, data set in this study is the Afghanistan Demographic and Health Survey, which was carried out by the Central Statistical Organization in the Ministry of Public Health of Afghanistan in 2015. Altogether, 25,650 households are included in this survey. The data set has one record for every child of interviewed woman born in the 5 years preceding the survey. More detail about the FDHS data sets are available in the FDHS 2015 report. In data cleansing, as I mentioned before, totally 32,712 records are available in FDHS dataset. The survey carried out had general purpose to collect information regarding all health issues in Afghanistan, not specifically for child mortality. For this reason, altogether 32,700 samples cannot be used and have to be eliminated due to their incompleteness. Finally, a total of 9,000 samples are complete enough for further analysis. And these 9,000 samples, the number of dead samples is less than the alive category. To ensure the validity of the work and splitting samples into 2 equal size categories ensures that a learning process is carried out on the basis of equal proportion of samples in each category, so that it's not overwhelmed by category with much larger sample size. We can see here from complete 9,000 samples, we have 7,500. We can see in the table on the right of the presentation. In 1,500 DIT category, we divide the original data set into 5 sub-data set, 5 balanced sub-data set, 1,500 samples from alive category in each data set, and 1,500 samples from DIT category. For the feature selection, as I mentioned before, feature selection is the process of selecting significant features for the task at hand. FDHS dataset totally have 1,187 attributes. Some attributes, for example, phone number, country code, mother names, date of interview, and etc., are not appropriate for the implementations. For this reason, we removed so many attributes from the 1,187. And we also have vigorous consultation with domain experts and doctors for selecting significant features and attributes for this task. Doctors and domain experts had expressed common 16 attributes. These are the common 16 attributes in the table, which was recommended by domain experts. For the success of implementing any determinant model, having relevant features are very fundamental. Physicians and domain experts suggested further reduction to 13 significant attributes. After that, correlation-based feature selection algorithm is adopted for its simplicity and ability to handle both numerical and categorical attributes. These are the top 13 attributes which was selected by the correlation-based feature selection. As we know, CP's algorithm computes the correlation between all features and the output class and selects the best feature subset. For example, CP's algorithm computes select the attributes which has high correlation with the output class and less correlation with the other features in the dataset available in the dataset. For the implementation of the predictive models, we applied different classification algorithms, namely k-nearest neighbor, neural network, neo-Bayes, random forest, and support vector machine. This is done by means of the most popular machine learning tools, Weka. To ensure the validity of the work, 5 models are implemented from each tool. The performance of each predictive model reported is the average among the 5 implemented models. For these reasons, the accuracy we receive will be not the chance accuracy. Yeah, the ratio between the training set and the test set is 80-20, as I mentioned before in the methodology diagram. For the evaluation of the predictive models, we used commonly used evaluation metrics, namely accuracy, precision, recall, and area under the RAC curve. In resultant discussions, as I mentioned before, we done so many experiments. Several attempts have been made to implement the most useful predictive model from each tool. The results are the average values from the 5 predictive models implemented. As I mentioned before, we divide the original dataset into 5 sub-datasets and we implement experiment on each dataset for each tool. This is the result average values from the 5 predictive models implemented in the study. As the result, random forest performed well for the all evaluation metrics used in the study. We can see in this table. Random forest algorithm obtained the best overall results when evaluated by all evaluation metrics. We can say it is not a concrete proof that random forest is superior among their other algorithms in all cases. But we can say that in implementing a predictive model using the ABDHS dataset, random forest is the most suitable classifier among the most popular machine learning techniques in this case. The predictive model provides a valuable tool to assess the mortality with relatively high accuracy and hence prevention of child mortality in Afghanistan in general. In conclusion, child mortality is perhaps one of the most crucial but avoidable global health concerns. Therefore, understanding the significant factors and implementing the most suitable prediction model for child mortality is essential in Afghanistan. This study is the first attempt to determine the most suitable classifier to implement predictive model for child mortality in Afghanistan using ABDHS survey. As I mentioned before, among the predictive models developed, random forest performed well among other algorithms. Furthermore, the result obtained from this study and the prediction model implemented are to be benefit for the child health intervention and health improvement programs in Afghanistan, which is underdeveloped country and highly skilled physicians are very scarce in Afghanistan. For future work, more detailed analysis can be carried out to ensure the order of influence of each attribute may have in child mortality. In conclusion, I want to also add, for example, doctors may save few lives, but prevention may save millions. Thanks for your attention. If you have any questions, please.
Okay, thank you, Hanasrat. Actually, your advisor is a friend of mine.
Yeah.
Okay. Anyway, any question from the participants? Okay. Else, actually, this is very, very good. I mean, this good. I mean, the research is important. I mean, to me, I mean, if we can basically get some knowledge about what is the key risk factor, right, that can affect the death of the children, then we could help. I mean, in some sense, even though I mean politically, I mean we cannot, but anyway, in terms of the technicians, I mean that is very good. But anyway, because you just wake up, right? So I think there are many, there are possible the feature selection technique, right? Information gain or whatsoever. So why you select? Maybe you adopt that. I don't remember, but that feature selection.
Yeah, very good questions. Very good questions. Yeah, as we know, there are so many feature selection methods. For example, PCA, principal component analysis, information gain, and etc. As you mentioned. The reason was at the first attempt I tried to use PCA, principal component analysis. The problem was PCA work more with numerical features and attributes. In my case, in my study, you can see more attributes are categorical. In this case, CFS is the good option to handle both numerical and categorical attributes. For this reason, I select the correlation between.
Excuse me. Can you also, I mean, go back, move your slide back so we can just get the idea what you, I mean, just refer to. Okay, thank you very much. Go ahead. Thank you. No, go ahead. I'm sorry. I mean to interrupt, but so we can just understand when you speak, explain.
Okay. Okay. The point is, as I mentioned before, the point is, yeah, there are so many correlation feature selection methods. For example, the Venn principal component analysis, PCA, and also information gain. The problem is in the case of dataset. In my study, many you can see breastfeeding, family planning, source of drinking water, and etc. A lot of attributes are categorical attributes. PCA, principal component analysis, have a good result in the case when we have numerical attributes. CFS algorithm have the ability to handle both numerical and categorical attributes. This was the main reason I select CFS. Yeah.
And what about your encoding method from the data set to the, let's see, the numerical ones, 10 or whatever?
Encoding method, yeah, 10 method. Yeah, for example, I could say breastfeeding. Are the child receive breastfeeding from mothers? Yes or no? In this case, I use if the mother give its own breastfeeding, do breastfeeding, we put 1 here. If it's not, we put 0 here. Yeah.
Okay, I just maybe just a suggestions. I think when you prepare the data set, I mean, you try to balance the data, right? For example, 1500 and 1500, right? But in fact, you don't need to. I mean, there are some, and you shouldn't do that actually. I mean, the data is very important, but there are some method. I mean, some learning. I mean, some technique that can work with the unbalanced data, and maybe you can get some more insight. That is just my suggestion. I mean, maybe
okay.
you can try.
Okay, thank you very much. For this reason, as I mentioned before, to ensure the validity of the work and the result and accuracy I received from the model is not by chance. For this reason, I divide the original data set 9,000 samples to two balanced category, 1,500 from alive category and 1,500 from dead category. You can see in this table. The main reason was, as I mentioned before, splitting samples into 2 equal size categories ensures that a learning process is carried out on the basis of equal proportion of sample in each category. For this reason, I divided the original 9,000 complete sample to balanced pipe balanced data set, and the result we received is the average from the 5 predictive models. Yeah.
Yeah, but to me, you don't need to. But anyway, okay, and because we can have some method work with the unbalanced data, that would be nice too.
Yeah, we use, for example, we have a smooth technique, and other techniques for balancing the data. For this case, the thing is we do not use artificial records. Smooth technique create artificial records for us. All the data and all the records are done from the actual and real records. For this reason, to ensure the validity of the work, we do the process
Okay,
like this.
yeah, we can talk later. I mean, if you interested work, I mean, further, fine. Okay, any more questions from the audience or suggestions? So else, thank you very much, Mr. Nasrat, and we will move on to the last presenter. So Mr. Roberto Bodo.
Thank you very much from your attention and your good suggestions and comments. Thank you very much.
Thank you very much. Thank you.
Good afternoon to all of you. Can you hear me and
Yes,
see the
please.
slides? Thank
Yeah.
you. I'm Roberto Bodo. Nice to meet you. I'm a PhD student at the University of Padova in Italy. My main research activities are predictive maintenance, continuous monitoring, and industrial machine learning. The second author is Professor Matteo Bertocco, a full professor in electromagnetic compatibility and quality engineering, and is also my PhD supervisor. The third author is engineer Alberto Bianchi, a chief manager of the R&D department at Current Industries SPA, which collaborates to the research by providing the case study and the domain knowledge in the HVAC industry. At first, the context of maintenance indication applications and the type 2 fuzzy set motivation are introduced. In the second part, the proposed system called fuzzy set aggregator is described, while in the last section, an industrial case study is discussed to check the validity of the proposed approach. In the industry scenario, smart maintenance applications enable to efficiently solve the maintenance indication task, or namely the scheduling of the technician intervention based on the estimated health status and the most probable occurring fault types. Such application, here schematized, are composed of a set of sensors, a sensing unit, and a fault identification unit. A typical problem in the industrial context involving third-party contracts is the development of closed-source algorithms. In this situation, if the field application requires a retraining of the fault identification unit and is not allow such functionality, poor performance is expected to occur. Retrofitting is thus needed to reduce the classification uncertainty and the time instability of the classifier prediction as the monitoring system ages. To effectively stabilize the classifier predictions over time and implement the needed retrofitting, a post-processing system should be developed having in mind the following requirements. First, the system should be context-free, or it should operate without any or little prior information on the fault identification unit and the monitored machine. Then the system should be able to adapt dynamically to the changes of the machine health status and possibly at low computational cost. Third, the system should be able to anticipate the intervention request to some degree to improve the scheduling margin and to lower the maintenance planned cost. We have implemented a post-processing unit called the Fuzzy System Aggregator, or in short FSA, exploiting the type 2 fuzzy set mainly because in this theory it's easy to model the management of uncertainty and its propagation, and because under the Gaussian assumption, the fuzzy modeling can easily be updated by using the closed form results of the Gaussian hypothesis, and because there is industry maturity of such applications in system maintenance. In the work, the following hypotheses about the input classifier are made. So the classifier predictions are the summation of a true unknown value, y of t, a Gaussian additive noise coming from the machine health status, epsilon with S, and a classifier noise supposed to be not significant, E of CLF. The developed type 2 fuzzy set model supposes that the machine health status, H, belongs to a superposition of classes in the y hat of t, which is the input classifier domain. So here exemplified as A, B, C, D, that partition all the possible machine health statuses in type 2 fuzzy set, the universe of discourse, capital H. The belonging to each class is expressed by the primary membership function mu, while the uncertainty about the estimation is modeled under the Gaussian assumption by using the secondary membership function mu2. On the implementation side, the FSA is composed of a series of processing blocks. At first, the channel divider extracts a binary vector for each class from the classifier predictions y hat of t. Then, moving average unit estimate the mean and the standard deviation for each vector by using the simple moving average or the exponential moving average algorithm. Next, the type 2 fuzzy set unit builds the fuzzy set by setting the secondary function to be Gaussian centered at with mean m and standard deviation sigma. Then, the type reducer transforms the type 2 fuzzy set model into a type 1 fuzzy set model through the centroid method. Then, finally, the defuzzifier decides what class should be indicated as output value. In this mechanism, we implemented two hysteresis mechanisms as explained later. In total, we tested 4 variants of the system. In the defuzzifier, the two hysteresis mechanisms are in black, the code reported for the classical hysteresis mechanism. So there is an interval and a threshold. In blue, instead, the previous mechanism has been modified by relaxing the hold interval of the hysteresis mechanism by evaluating a second threshold, which is in this case the slope of a linear regression calculated by a beta function. This method is called beta trend hysteresis in the following discussion. So if a centroid value does not satisfy a magnitude threshold in black, but exhibits a strong trend controlled by the beta trend threshold over a specified window, then the output is still updated. This will be later shown to be a crucial point to improve the anticipation degree and the maintenance scheduling margin. The case study discussed reports an industrial humidifier equipped with a fault identification unit that must perform the maintenance indication task. The 4 classes are baseline, abnormal, mild, and full, which implies a full restoration of the system. A run to failure statistics in this field is practically impossible. So an expert elicitation process has been used to obtain a simulation experiment. Classifier predictions has thus been modeled by a discrete stochastic process when weights are assigned by the following graph, Py of t. While T2 and T3 points are the first maintenance point, here indicated, which are the reference among the 4 FSA variants are tested. The plot above show the type 2 fuzzy sets built around the T3 point, which is the most uncertain one encountered in the simulation. Here we can see how the type 2 fuzzy set formulation together with the centroid method are sensitive enough to make an effective distinction between classes. On the graph below, the centroid dynamics after the type reducer obtain and the output signal of the system in output are obtained. So this is the T2 reference point and T3 reference point to compare with the purple signal, which is the reference signal for performance comparisons. The box plot above helps to visualize the results of the hypothesis tests. In particular, we can see that the A and B variants that use classical hysteresis mechanism are not able to anticipate the point T2 and T3 reference, while the C and D variants that use the beta trend hysteresis instead provide an effective anticipation margin on both the T points. To test the FSA output in presence of uncertainty related in this case to the expert opinion, the mild class, which is represented by the green triangle, the mild is the class in which the maintenance requires the substitution of consumable parts, so it's not a full restoration of the system. The mild class has been shifted as the result of the first test, and the slope changed to represent a decreasing uncertainty degree on the expert opinion. The distortion effects visible in the graph are due to the normalization of probabilities to 1. The sensitive analysis showed the different behavior of the FSA variants to the change of parameters, while all the variants are pretty insensitive to steep class transitions, as reported in the T2 point. The C and D variants are more sensitive in presence of small perturbations around a decision boundary, like reported in the previous graph in this situation, which is in this point of the plot. However, it's interesting to notice how the beta trend mechanism of the C and D variants can increase the anticipation performance in presence of increased uncertainty caused by slower class transitions. So, in this test where the green triangle presents a slower slope change, which is translated in a higher uncertainty degree of the expert, in this case, the performance of the system increases. On the contrary, the classical mechanism...
Sorry to interrupt you.
Sorry?
Hello?
Can you hear me?
Yes. Sorry to interrupt you. We have a time limitation, so can you conclude fast?
Okay, one more slide and I'm
Okay.
finished.
Got it.
Thank you. To sum up, the work proposes a post-processing system called FSA, and an industrial case study is also reported to test the method. The verified hypothesis show that the FSA variant using the exponential moving average together with the beta trend hysteresis provides the best performance. The anticipation also increases against an increases uncertainty on the dynamics. The best variant provides, on the average, a valuable scheduling margin for predictive maintenance purposes. The presentation is over. Thank you all for the attention, and I leave my contacts if you need further information or comments. Thank you.
Thank you very much, Mr. Roberto. Any questions? Maybe just a quick question because it's time limit anyway. And it's going to be the last presenter. So any question or any one want to share the experience to this research particularly? So else, let's see. I don't have many questions, but just only one question is: what about others approach, not just the fuzzy-based techniques? Have you tried all, or what is the key insight that the fuzzy type 2 is the best to fit with this particular problem?
The motivations of why we used such technique instead, for example, of Bayesian networks and other methods are because we seek for robustness in the signal processing of the classifier input predictions, and because we seek a dynamical adaptation of the system at a low computational cost. So, by exploiting the closed form results in the Gaussian assumption, we are able to keep the computational cost very low.
Yes, but what about others? I mean, it's good if you can just do maybe it's a quick analysis of other competitive. I mean, I mean, because you claim that those are maybe the costly, right? Or maybe it's not dynamic. So if you can just maybe in the motivation, specific example or some or any one, I mean, any other, I mean, people, I mean, do that for you. They have survey to confirm that here, right? Because this is what you claim, right? You can make it, but what about others? That's my point, right? In terms of you have to show some proof, for example, or maybe some simulation to support your claim. That's it.
I skipped maybe the statistical validation of the test hypothesis, because in this case we can see on the average a result that which is satisfying the specifications.
Yeah, sure. But just wonder if other also, I mean, meet this, I mean, satisfaction or not. But anyway, it's good. I mean, it's a new approach, hopefully, and that can work with that. And if you develop the closed form, that's I mean, reduce the time complexity a lot anyway. And and any industry adopt this model into the actual, work yet?
We are planning to embed in a humidifier controlled application in the industry, in the HVAC industry, which we are collaborating with one of the author.
I see. And what about the, in the current work, do they implement any approach, for this in the industry wise?
Just counting the operating hours and scheduling preventive maintenance. So you count the operative hours of your parts and decide whether to replace preventively before the incipient failure.
Okay. Thank you very much. And any other question, suggestion from the audience? Else, I think they all provide some email. You can just have some
Yes.
network. So for any question, we can just send an email, and then even me myself, you can find my email contact easily. Just Google, and I'm happy to work with all. Myself recruit postdoc, or because now machine learning is here, right? We just do some machine learning based deep learning or whatever for actually almost all of the area, right? Because now the machine learning is in implementation era. It's not theory anymore, right? We just implement the machine learning. So I think all of you, are expert in the machine learning. So I think we are in the same, community, same society. So, and then please, keep the networks, any question. And I think this conference is very good. Thank you for the, the share and this conference that, can have us all around the world all meet together, right? And I think the COVID has some good that we can have the virtual meeting, right? Actually, in my country now it's like a midnight, but still, right? We can talk. And anyway, I keep the network, and thank you very much that all of you are here. And I think can we just have the nice snapshot on the figure? Can you just all turn on the video so we can just make the capture? I very appreciate that.
Thank you.
Let me see. I'm just waiting for a few. So okay. Can you just yeah, let's wait a bit. It's gonna be a nice picture. Just wait a bit. Mr. Muhammad Abdi and Conrad Rugam Natif Singh. Can you you are not here anymore? Okay, fine. Then just smile. Then okay, 1, 2, 3, and yeah, sure. Okay. Oh, it's the blur. Let's see. It's a blur. Let's see. Why is it blur? The coordinator, can you just take a picture for us?
Yeah, I'll do that now.
Yeah, thank you very much.
That's all right. Yeah, I've got it. Thank you.
Yeah, thank you very much. All the presenters.
Thank you.
Any question, just email me and email the chat, and hopefully next year we can just see again, or some of you maybe graduate. Then I think we are welcome to work, all together. Okay, and keep in touch. Okay, bye bye, and thank you very much again.
Thank you.
Thank you. Thank you.